catching up the YouTube audience, we've talked about nothing except my inability to see the future. Okay, so in any case, here's the class webpage. And the class webpage shows us the topics we're going to be covering. And there's three major colors here, and they represent the three major conceptual pieces of the course that you'll be learning. The first piece will have a little bit of overlap, or maybe some overlap with 354, I believe, which is about virtualization of the CPU and memory, and we'll do that from a bottom-up way, and we'll start doing that today. So that's in orange. Then we'll learn about concurrency. That's in the kind of bluish color there, where we'll learn all about threads and locks and other primitives and problems that people have in creating concurrent programs. And then we'll have the third part of the course is talking about persistence of information and file systems and all the techniques that you use to build those kinds of that part of the operating system. And then at the end, we have some room to do some kind of miscellany. Sometimes we do distributed systems a little bit. Maybe this time we'll try to do a little bit of security because it's so much in the news. I mean, how crazy is it? This is, for me, it's every time, still today, it's crazy how much nerdy computer stuff is in like the front page of newspapers. When I was first interested in computers, that was not the case. The world has changed quite a bit, of course. So that's all the structural material here. Let me click. I've told people in the past, just click on these links and read them. I find that at the end of class when I survey people that not many do that because apparently everything I say isn't just immediately followed by everybody, which I struggle with. So I'm just going to go ahead and do it for you, and that way we can know that we all looked at it. This is the course overview. It's very enthusiastic to the point of, whatever. So anyway, it tells you what the course is about, and it tells you all the things, a little bit what we've said already, like you should know stuff like 354 and C and 367 and how to program. It talks a little bit about materials, so this is a good time to talk about what materials you'll need for the course. One thing we have done over the past so many years is when my wife and we would teach the same course and we'd kind of share notes, and eventually we turned that into a free operating systems book, which is free in the sense of it's online. Each chapter is online, and you can just read them online or print them out or whatever. We also because people ask for it, we sell some printed copies and like a DRM-free PDF of the whole thing for like $10. But there's no reason to spend any money if you don't want to, because the whole book is just here. And I'll show you how, like on that first web page, when we talk about various things, we link to the chapters right here. You can see, for example, like the intro chapter here is linked just off of today. So that'd be a good thing to do is, that's the kind of associated reading with class, okay? So let's go back to the overview real quick. So that's the major conceptual material of the class is in that free book that we've created here for your reading pleasure. Then there is the project side of the course. The projects will mostly be writing C code. So that means you're going to, however good you are now, you'll have to get better, unless you're already some sort of expert, in which case, congratulations, that's a great thing to be. So usually it's hard to imagine a computer scientist who does not have the C programming language book. In some ways, it's actually not a great book, but it's the book that everybody has. And in other ways, it's written by the people who created the language, so it's a little funny to criticize them. But it's a good book, and it, of course, has many things that are worth knowing inside of it. How many people already have this book? Okay, how many people are now regretting selling that book after the last time they took a class with it? Okay, you don't have to raise your hand. So that's a good book to have on your bookshelf, and probably that's the case for all these books, that you can find some sort of copy somewhere in the world. I won't say where. So that's really probably what you need. There's another book that I wouldn't say recommend, because then people will go out and buy it. I would say this is a book you should know about. And if you're going to become a serious systems programmer, you should at some point acquire. And it's called Advanced Programming in the Unix Environment, whatever the latest edition is. This is kind of being a C programmer is one thing, you're writing little algorithms and data structures in C, but interacting with the OS and understanding what are the real semantics of these system calls and the services that the OS provides you, that's a much different kind of skill and requires a much different knowledge. And that book, which is quite large and quite comprehensive, talks about every single detail that you need to know to write robust systems programs. Do you need that in this class? I would say no. you don't need it. But it's just something that I would feel remiss if I didn't point you to as an excellent resource for those subset of you that are fascinated by computer systems and want to do more on your own. Another book that I really just enjoyed when I was learning C is this book. I think you can still get it. Yeah, it's called Expert C Programming. It's just a great view on C programming that gives you a different perspective, a little deeper in some regards than K&R. And then I guess there's this free thing that I found by Zed Shaw. It's called Learning C the Hard Way. If you just want to do some exercises, that is like essentially if my link is still working, this is a way to kind of do some C exercises and get back up to speed. If you haven't done any C, it's going to be a bit of a tough slog, and I don't think this is a great course to take. If you haven't had many 500 level courses or any, it's probably not the good first course to take because it's going to be a bunch of work and we're going to get right into it. So just be forewarned. Anyway, this web page doesn't work. I told you that web thing wasn't that good. So in any case, so that's basically materials. Mostly, there's a free OS book, which is our conceptual material, which will be most of what lectures are based on. And then you have to know C, so make sure you figure that out, and we'll get into that. And then the other thing I just kind of list here are a bunch of other textbooks, OS textbooks, because we give one perspective on the world, and this is really for the 5 or 10% of you who are really interested in operating systems as something you want to really learn about in great depth, as opposed to just a good working knowledge. Having a different textbook is always a great idea because you get multiple vantage points. The slight disadvantage of this class is what I'm saying is what became the written book. So then when you go and read the book, you're going to be like, this is what you said in class. And you're going to be mad that it's not the different perspective on the same thing, because it's nice to have two different perspectives. So for that, I kind of apologize, but that's just kind of life in this course. You're going to get the one vantage point. If you want a different one, you should get a different book. Okay, so that's materials. Any questions about that? Make sense? Okay. Okay, so technology-wise, I'm quite backwards, so I don't use a lot of fancy stuff to run this class. I use what's called email and the web page, and I really don't use anything else. Why do I do that? There's a lot of reasons. Some of them good, some bad. We can have a discussion about them later. But one thing I will do is, and I've already done this, is I've sent an email called a test email to the class list, and I will mail anything that's important that's going on in class, I will mail you. So I assume, what does that mean I assume? I assume that you read your email occasionally. Now, I don't know if people do that. People have so many different ways of communicating, but you should assume that you may see an important email. Now, you may, if anything's important, it will also be reflected on the class news part of the class webpage. So if you're either looking at the webpage or reading your mail, or preferably both, you'll have enough information to know what's going on in the class. Oops, going the wrong way. So that's that. Now, in terms of what you do, a lot of classes assign homework. Here we have, like the book chapters often have little homework exercises at the end. We just recommend those. The reason I do that is because you already are going to have a lot to do, honestly, between all the projects that we're doing. We'll talk about the load of that in a second. So I don't want to add an additional burden. That said, those are good ways, those homeworks, which are often little programs you run to see if you understood, like the chapter you just read, are really good ways to keep up to pace with, see if you're understanding what's in class. And certainly, if you know about the genesis of where these little homeworks came from, you'll understand why it's important to do them. It's because at some point in the past, I was teaching 537, and then I created what I thought was a really good exam question, okay? And then that exam question was so good, I'm like, oh, I should turn that into a homework problem. And then pretty soon, what are really all these homeworks are things that could appear on an exam. So it's a good way to practice for exams is to just simply do those homeworks. So that's optional. I will not check anything about that. You will start to wonder a lot about it probably right before an exam. Or otherwise, it's a good thing to do as we go through the material. And we'll look at some of those in class too as we have time. Okay, now let's get to the parts of the course that actually you do have to do. One thing is, it's kind of you can think of the course as two pieces. One is projects, and the other is exams. So projects are you're writing some C code to do something. There's actually two flavors, and that's so half your grade of projects, half your grade are exams. There's two flavors of projects. The first flavor is what we would call systems programming. So you're using a Linux machine, and you are basically just writing some C code that interacts with Linux to do something interesting. Like there'll be a warm-up project, there'll be something like you create your own Unix shell. There's a few other things like that that we'll do. Sometimes we've done things like write a distributed file server. We've created a concurrent web server. We've done a concurrent search, like a concurrent crawler of the web, which is kind of a, before you do search, you have to crawl the web. We've done a bunch of projects like that. Those are all implemented just on a Linux machine and just writing C code that interacts with the operating system. And so all that work is going to be done on, it's going to be tested on departmental computers that run Linux. So there's a bunch of labs. You can either go to the labs or you can log into them remotely. You're going to have to learn to do one or the other. And there's a list of the machines here, which I just link off of. This says, you can't read this, but it says here the instructional facilities. And how many, you've used these Linux machines before? Yes? Okay, good. So you know what I'm talking about. You know how to log in, etc. If you don't, it's going to be a long semester or a very easy semester until the end, where you realize you then have to take the class again because you never did any of the projects. So don't do that. A lot of project advice, which you always feel funny saying, but I'm going to say it anyway because I'm, of course, assume some level of responsibility from you. Now you're, getting older. Let's all admit it. You're getting older. What year were people born in here? What's like who's the youngest person in here? Let me ask that. Who thinks they're the youngest? Yeah. 2000. Can anyone beat that? Yeah. Everyone's like, oh my God, that guy's a genius. Yeah, and he just got his PhD in physics, so just decided to switch fields. So that's awesome. 2000. I knew that point would happen, and I've been kind of ruining that day where I am teaching and people have not been born in that century or millennium. I guess that word, I don't know when that changes. It changed 2000 or 2001, but they were born in a much different time than I was, which was unfortunately 1971. So in any case, why am I talking about that? It's because you're all old enough to be responsible to know that you have to do a bunch of work, and I can't sit there and watch you all doing the work, right? What's the difference between being in high school in a small school and then being at a huge college like this? Well, I know for me, the difference was at some point I realized, and like I said, I was at Michigan, so it's a very similar feel to this, like big public, Big Ten university, is I realized like literally nobody cared if I went to class, if I died, if I was sick, all those things nobody cares about. The only thing they will notice eventually that, you're like the checks stopped coming to the university, right? They would notice that, and then they would get, maybe interested in, hey, did he die? Was that what happened? Or is he just lazy or whatever, or delinquent? So that point, that was a very freeing realization because I realized that meant that I had to be in charge of that. So I'm assuming that of all of you. You have to be in charge of your own education because I can't pay attention to all of you as much as I would like to, right? It'd be nicer if, everybody had a guardian angel over their shoulder telling them to work on something or you should get this done, but that doesn't exist to the extent that one might need it. So please be responsible. Don't procrastinate. Start things early to see what problems you're having. All these things which you will eventually ignore because you have lots of things going on, but you should do them. In terms of grading projects, just to be clear, we're going to be grading things based on how they work. So pretty code that doesn't compile or doesn't pass any tests is going to get us same grade as bad code that doesn't compile or doesn't pass any tests, which is a bad grade, so like a 0. This is the harsh reality of 537. We are very test-driven, and we will share most of the tests with you, so you should be able to tell before you even turn in a project how you're going to do on it. So this is great news and bad news because it means if you're not passing tests, there's no magic. It's not like an English class where you're like, well, I know this essay's terrible, but I'll turn it in. They have to read it, and it does have words in it. It doesn't work that way in here. Here, we're supposed to become people who build code that works. There is no CS professional who builds a bunch of code that doesn't. Well, that's not true. There's actually a bunch of professionals that build terrible, bad code, but that's not going to be you, and it's definitely not going to be you in this class. So that's life. Last thing I should talk about, because clearly it comes up, is don't cheat, or what we call academic misconduct, or what we call cheating. Don't do that. People sometimes ask what's okay, and what is most cheating? Most cheating is not people who are bad people. It's people who didn't plan and ran out of time. right? It's mostly like, oh, I really have to turn this in tomorrow, but I'm not going to get it done. Hey, can I look at your code? Hey, whatever, sure. And then things are problematic. I'd much rather have you say, hey, I really need an extra day for a project. Can I turn it in a day late? Please do that. I will be generous to that, as opposed to the opposite, which is, hey, I ended up just kind of using somebody else's solution. So please don't do that. And in the end, who are you cheating? Well, of course, your peers who are, in a competitive environment with you, so that's unfair. But of course, you're here to learn things. Sometimes we forget that these are things we're learning so that we can be good at them later on. So please don't do that to yourself. What you can talk about, though, is you can always help each other. We don't want to create an environment where you're worried about talking to each other. So when somebody asks you, hey, how does this thing work? You can talk to them about it. If they say, my code is buggy, can you help me debug it? Sure. Now, what does that require? That's a lot harder than cheating, right? It's a lot harder than sharing your code. You say, I don't have time to talk to you about your code, look at mine. That's easy. Don't choose the easy way, right? The hard way is you sit with your friend, or even worse, somebody you don't like that much, and you help them figure out what's going on with their code. That's perfectly okay. Please do that. That sounds like being a good person. So do that. And don't do the other thing, which is just expedient and doesn't get us anywhere. And then, of course, be reasonable. Like, if you're getting help from somebody, don't ask them for help 300 times, right? Just, try to be a reasonable person and try to realize that all these things take time. Like when we do, there's part of the, we'll talk about the specifics of another type of project. We have two types of projects. I only mentioned one. There's some type of project that you just stare at the code for hours, and then you figure it out and you write 10 lines of code. So that can't be replaced with, just like, hey, how did you do this? You're missing a big step in the learning process, so don't do that. Okay, so and then there's a little bit on this page about how to make sure, like once in a while people are code is stolen from them without their knowledge. So make sure you work in a private directory. There's a little bit of detail on how to do that inside of AFS, which is our shared file system on Linux machines. So read the cheating page for that useful piece of information. Okay, so I talked about one type of project. There's another type of project. So we do these projects outside the kernel where we write systems code for Linux. Then we do this other type of project, which is in the kernel, in a little learning kernel called XV6. It's basically a port of one of the original Unix operating systems called V6, a very classic version of Unix. And it's been ported by some people at MIT to work on modern x86 hardware. And so we're going to use that as our inside the OS learning environment. So about kind of half the projects will be inside that world. So that's projects. That will be what you spend most of your time on. Almost the one thing you'll have as a constant this semester is when you finish one project, guess what will happen? Another project will be released. And you'll be really excited, because how could you live without having an OS project hanging over your head? And at the beginning, they'll be pretty quick, because we want to make sure that you kind of get up to speed, and then we'll have a little more time for them later. But the first ones will be simple. Later ones will be more involved. So those are upcoming, and the first one will be released tonight. Actually, when I get home, I'll add it to the webpage, and you can start looking at it, and we'll talk about it more in discussion. And yes, it's due very soon. It's due like Monday. So already I've ruined your weekend. Remember, we want that, right? It's like the cold water in our face. We like to have that, right? When you're like tired, you throw the cold water on your face. This class is that cold water. Okay, so that's projects. Let's talk a little bit about exams. They're the other 50% of your grade. They're already scheduled. Those are the schedules. The midterm, which covers first 60% of the class. The final covers the final. We'll have locations announced at some point. Those will be, covering what we talk about in lecture, and a little bit assuming some knowledge about the projects. And what I'll do is, as we get near the exams, I'll kind of forget about the exams for a while, and as we get near the exams, I'll release, here are old exams that I've given as examples of things that you can look at and study from, as well as, of course, homeworks from the book and the book itself. Question?
What should we do if we can't make the midterm date? Because there's another CS 500 level class that's a midterm scheduled at the same time.
Really? Because, in the CS department, there was a shared spreadsheet, and I put on there this date before whomever this person is. So which class is that?
CS 524 is taught by one of us.
How How many people are in this class? 524? Okay. So clearly this can be solved by 5 people dropping 524. I'm here to provide solutions. So unfortunately, with a class of this size, even if you didn't have that particular issue, there's somebody flying to Aruba that day because it's only 3 days before spring break, and of course that's when I travel to Aruba. There's somebody else who's sick. There's somebody else who had a distant relative fall ill and they need to travel. You'd be surprised all the things you hear, reasons people need to not be at this exam. I'm sure we'll have an alternate, so it probably won't be a big deal. But the alternate's really for the few who are in 524 or traveling to Aruba. So those are the 2 things, or maybe some other thing. So we'll talk about that as we get near there. And we'll talk more about the exam as we near there, and otherwise we will forget about that because we shouldn't focus too much on these things. We should focus on trying to learn something and have fun in the class. Other question, yes? Oh, great question. So question is, if you couldn't hear it, are the programs individual or with a partner? The answer is actually yes, because at the beginning, you're kind of stuck by yourself, so you can make sure you know how to do something on your own, and then after a couple projects, we'll join forces and do slightly larger projects in groups of 2. If you are not able to find somebody, we will help facilitate that, but it's not bad to, reach out, look to the people around you, sit in different locations, small talk, talk some technical talk, see if you can find a good partner. That's not a bad idea. Yeah. Right. So as I talked about, I'm very technologically challenged, and so I wasn't planning on using anything that creates a lot more work for everybody. But I've a little bit my issue. So this is 2 things I want to deal with. One is there's help on projects. Projects are like, you show me your code and I help you with it. I don't see a reason to have a shared thing for that. So people just send email, they put code in a place we can access it, a public directory, and then we go and look at it. So for that, I think that works very well in the way that we do it. And when there's ever a shared concern that comes up on 3 emails, I just immediately clarify to everybody. So I don't like the idea of using kind of a Piazza-like thing for that. Now, if around conceptual material in class, people think it would be useful, why don't we do this? Let's wait a week. And if at the end of that, people are like, I really wish, hey, you talked a lot about process virtualization or whatever, virtual memory, and I didn't understand it, and I wanted to have a place other than just talking to you directly, Remzi, even though I really enjoy that. I wanted to have a place where I could talk about this with my peers. Why don't we wait a week or 2 weeks and decide on that and see if it's a need. I haven't done it in the past, like I said. What I get concerned about is it's another thing you have to pay attention to, and another thing you have to read a lot to make sure you didn't miss something critical. So I try to a little bit control the flow of information so that you don't feel like you have too many things. But I guess at some point, even I have to change. So and what better thing to do than to support another startup in our field, Piazza. So I'm pretty sure I'm linked in with the founder. So maybe eventually I can get some sort of stock benefit out of this. No, I will not get a stock benefit out of it. Okay, so other questions about how the class will run the machine. Each class is a machine, right? You have to figure out the machine and how to work the machine to your advantage. So you learn something, but you don't kill yourself working too hard, right? Yeah. Right, how many projects? So the answer is every semester that I've taught this course, the answer has always been more than the last time. So I've been doing that until the point where the students will not take the course, and this is the biggest offering I've ever taught. Therefore, I conclude you all want more work. He's going to tell me that's not true. I'm not going to answer that question. So anyway, so in any case, what happens is at the end sometimes we have a little flex. So the way I talk about the class is having kind of 5 large, what I call 5 projects, but each of those is actually kind of 2 projects. So that's kind of like 10 projects. But sometimes we don't get to 9 and 10, or sometimes we don't get to 10. Each of those is some kind of programming assignment of varying length. At first, they're very small. By the end, they're somewhat substantial. Like I said, the ones at the end are done in pairs, so you have a little bit of help. Is it a lot of work? I think it is. But, if it's hard to tell from my side, right? Because all I can see is the suffering in your faces. And it's never looked that bad. It's always like, oh yeah, that was pretty interesting. Once I got into it, it was a bunch of work. Where it's hard is if you're struggling as a C programmer, the course is going to be hard. Because then you're doing things like, my program didn't work, then I put some ampersands in there, and then it kind of worked. Then I put some stars in there, then it worked even better. Then I added one more star, then it crashed every time. This means you're not ready to take this class, right? This is not a good time to do that. You have to be solid on those very basic fundamentals. In C, it's the runtime stack. It's so how function call and return works. It's pointers. Right? You have to feel comfortable with those things because you have to get to the point. Otherwise, what are you doing? It's like, hey, I'm in a kitchen. All these knives are here. I'm going to throw them up in the air. That sounds great. Hey, where are they landing? On my head. That's what happens when you throw knives in the air in the kitchen. So that's what C programming is when you're just throwing characters at the text editor, hoping it works. Like getting it to compile, getting it to run. I mean, these are not what you want to be doing as a C programmer. So if that sounds like you as a C programmer, think about maybe not taking it this semester and figuring out how to brush up on that stuff, or really get to work and get yourself going early. Any other questions? Machinery of the course. It's sounding like work now, isn't it? That's always the dread. I always look so excited. You go to class, what's this person going to be like? Is it going to be fun? What am I going to learn? And then the reality sets in. There's a bunch of work ahead of us. But what is there but work? Work is what we all are doing, right? Okay, so that's the overview. Let me talk about a couple other things to depress you further. I'll put links to course videos here. That's under a page surprisingly called videos. There is a link to all the homework that you don't have to do but is recommended here. So that says here's a chapter that you might read and some code you might run. And those little pieces of code you run, like they're of this flavor that they generate kind of random questions. So like like give different inputs and things like that. So you can create as many homework problems as you want, which is kind of cool. And then they can solve it for you, tell you if you're right or wrong. So that's that, and we'll talk about a few of those in class too. If we have any handouts, they'll be here. And like I said, the book chapters are indeed linked over here, like as related to class, but the whole book link is over here too. That's at, the book is called Operating Systems 3 Easy Pieces because it's about those 3 parts of class, right? Virtualization, concurrency, and then file kind of persistence in file systems. And like I said, just looking at this book page, you can see there's a hardcover you can buy. I don't remember how much it costs, 36 bucks. There's a soft cover, it costs $21. It takes a little while. Each of these are printed on demand. I didn't want to work with a publisher because when you work with a publisher, I said, can you make a cheap soft cover? They said, sure, as long as it's $80. And I'm like, I can self-print these, one printing at a time, and sell it for $20. And they're like, yeah, but then we wouldn't make any money. So I said, okay, maybe I won't be working with these publishers. So that's why we just self-publish it. And then there's a $10 DRM, which is always the latest version of the book. So as the book changes, if you happen to buy the DRM free latest edition, you can always download the latest one, which is just the PDF of all the chapters kind of smushed together. It's kind of a way to, people wanted a way to support the book and get some small thing out of it. 3 people said that they wanted a t-shirt, so we have a terrible t-shirt that we sell. That really doesn't sell at all, surprisingly. Whoa, that's a way too close. So anyway, that's the book, and it's linked here. And like I said, the chapters are. Let me zoom in a little bit. The chapters are linked as per per each day's material. Yeah.
So like there's 7 chapters in this lecture. Can you roughly summarize how much reading it's going to be, like pages or hours wise?
Yeah. This one is 1 page. There's these kind of dialogues in the book that are just kind of supposed to be funny. Your mileage may vary on how funny they are. Then like here's a little intro chapter. All the chapters are meant. So the way I did this writing was I did it in the style of like almost like a lecture. So literally how the book got created was I just had some extra time, and as I said, Andre and I developed this course, and then I would just go to my office and kind of write what I just said, and then it's been modified a little bit since there. So it's kind of just a pretty very casual. It's not like a textbook which is trying to know everything. There's really 2 types of textbooks. There's ones that are references, where they're like, here's everything you need to know. And this is not that book. This is a book that's like, here's a way to think about the conceptual things we're learning. So each of the chapters are pretty short, actually. So if you see you had to read 3 chapters, it's not going to take you that long. Yeah?
From previous offerings of this course, do you have any data on how many hours the average student spend
Yeah, so the question's about, do we have data about how many hours people spend? I don't have any hard data. The problem is, the reason it's hard to get good data on how many hours you spend is it depends so much on, like, am I struggling with C? If I struggle with C, people will say, I spent 40 hours on this and I passed 0 tests. And everyone feels bad about that. Me, I feel bad. I feel like I failed as a teacher. And you feel bad because you're definitely going to fail as a student, right? Unfortunately, only one of us is getting graded, so a little bit asymmetric. But the reality is, of course, I feel bad too in that case. And so that's the case that you want to avoid. Like, I don't have the ability to walk, so I can't run in this class, right? I'm not able to do the basics, so therefore everything seems hard. And beyond that, like let's take this first assignment. The first assignment, which I'll talk about in discussion, and I still have to talk about discussion because something changed there, which is important, which is the time of the discussion. So the discussion, I'll introduce the first project. A person who knows C will finish that assignment in half an hour. It won't take a long time, half an hour, an hour. A person who's struggling with C, it's like unbounded. So I think they're actually pretty reasonable. The thing that's troubling is it's just hard to know when you don't feel sure of the basics. So the first thing you want to do is brush up, feel good about C, remember those conceptual things you learned in 354, or you can learn from K&R or other online resources, and be solid on that. Everything becomes so much easier. I do have a little bit of data which I can dig up, which is just kind of asking at the end of the year before. But I think people, in the end, when people ask others, hey, is this course a lot of work? What do they say? Yeah, they say yeah. So either they're lying or it is. And, I always tell students, be careful of what other students give you as advice, but then in the end, that's, probably good to talk to your peers. It's a fair amount of work, I think. That's how you learn in the end. So, there's old saying, right? I even probably quoted in the book. It says like, I hear and I forget, I see and I remember, but I do and I understand, right? It's an old saying. And that's why we kind of want you to do things, right? Because when you do them, you finally say, oh, that's what he was talking about in class. So we all suffer together, but like I said, you do more of the suffering. So great. Oh, I guess that kind of brings up the class motto, which I'm remiss not to tell you before we get towards our second break. The class motto is, it always gets worse. So you get through the first few assignments and you're like, that was pretty bad. And then you're like, how's it going to be in the future? And I'm going to say, it's going to be worse than that. And that's reflected in the book too, because like the chapters get longer and more complicated. One thing that's really great about having like an online book is I encourage people to give feedback from around the world. Actually, I get email probably every day or two from random students or faculty about the book. And this It Gets Worse was reflected the other day when I got an email on chapter 28, which somebody said, this chapter is really terrible. That was their feedback for me. So I thank the student for that insightful commentary. My kids told me, please take a day before you respond sarcastically to this poor student who doesn't know how to write a critique of your book. So I did take a break, and I was pretty nice about it if you're worried. But in any case, if you do have feedback on the book, mostly think about it, but please feel free to send it to me. Okay, so one thing about discussion. What got screwed up in scheduling of this class is I actually like to run discussion instead of having TAs run discussion. Not that TAs, of course, would do a great job, but for whatever reason, I like discussions because discussions are me plugging in a laptop and just showing you code that's going to be useful for the project. Now, the problem is, usually when I teach it then, a single discussion gets scheduled. And as you notice, there are 4 discussions, which are all back-to-back in different buildings across campus. And while I am, as you might have guessed, incredibly fast, I'm not that fast, nor do I want to do 4 discussions back-to-back. So what I've scheduled as an alternative, which may not work for everybody, but it'll be okay, is 1 discussion. So all those 4 discussions are virtual. You have to just be registered for one. And we have the actual physical discussion. This is like class. There's virtual things and physical things. So you're scheduled for some discussion at some time, which I've forgotten already. But the actual physical discussion will take place Wednesdays at 5 o'clock in here. The good news is if you can't make that, it's okay. Those are always recorded, and the video is available immediately after the discussion. So if you can't make that time, it's okay. I apologize if you want to be there for the live thing but can't make that time. And that's when we will usually do it. Sometimes I will already have a video that's perfectly good, and I'll just share that and we'll skip discussion, but mostly we'll create new ones. So we'll be back here tomorrow, better or worse, if you want to be, and we'll go over the projects. And those discussions are pure project. Lectures are pure conceptual material. And like I said, if you can't make it, it's okay. So that's important. If you know somebody who's in this class and hasn't looked at the webpage and is about to go to discussion tomorrow, please tell them not to do that and instead to go to the actual discussion time. And for that, I'm sorry. That's a bit of a scheduling problem. I'll blame the administrative folks, but it probably is my fault too. Any questions about that? Does that make sense? Everybody hear that? If you heard nothing else tonight, discussion is actually not at the time you think discussion is. It's at 5 o'clock tomorrow in here. Fortunately, this room is apparently empty a lot. So amazingly, this room can fit like 400 people and only get mildly uncomfortably hot. Okay, so that's the course overview. I don't think there's much else there. Any other questions about how the course will run? Okay, great. So why don't we do this? Let's take another break. Wow, this guy's giving me so many breaks. Let's take another break, and then we're going to actually do back to lecture mode and material mode and get into the beginning of the course, actually. Okay?